So the next speaker is a hands-on engineer with a track record in the hottest projects over the last few years. He has been responsible for the architecture, scalability, and performance and system behind many markets for hundreds of millions of customers. Right now, he's working as an architect at Æternity and coordinating our decentralized team of developers. So please welcome Michal Zajda. He's getting prepared with his presentation about consensus and the Stratum protocol. So a warm round of applause. Come on, guys. He's getting ready. 5 seconds. Yeah. Okay, I will say a couple more things. How was Amin's presentation? Was it good? Did everybody enjoy it? Okay, yeah, Michal is on. Yeah, go on, Michal.
Hello, 1, 2, 3. Yes, we are on. Perfect. So you know my name, and the the title is Eternity, Consensus and Stratum, even though the presentation was supposed to be about Stratum protocol. Stratum itself represents a little bit more than its definition because it's about pool mining software. So it's impossible to make presentations only about Stratum, and to understand it, you need to know a little bit more about Eternity and consensus we use. So let me tell you something about it. I'm taking care of protocol development in Eternity, and let's begin. Right button, yes. So good thing about long title is you don't need agenda slide. So as I said, let's have crash course on Eternity consensus, and you will see what kind of features and nice things we have from it, and also what challenges we meet, and that's the challenges form rationale behind implementing pool mining software with Stratum protocol. Why it's all connected? Why we have to go all the way? The story begins 27th of November when we launched mainnet. It's of course it was around midnight. I remember the day. It was exciting, and still, yeah, I see familiar faces today, and they were present back then. Even though it was baked for a decent time, we thought we are prepared. We still got surprised. We got surprised. I want to tell you about the positive thing we got surprised with. The thing we got surprised was pretty large computing power that took part in mining the chain. We are proof of work chain, so it's important to build a community of miners. But the amount of miners that got right away to mining main chain was amazing. Over the first couple days, regular users were no longer influential, so we had to take rapid steps to empower them even more. We created more efficient GPU miners. We improved heterogeneous configuration, so basically whatever you had in your system, spare CPU, spare GPU, you can compose the config file of the full node in a way that it's all used. But soon the mining power was so big that it was not enough. So what got on board was generic regular frameworks for doing pool mining. Great, that's great. But here the challenges begin. Eternity, to deliver its features, its great promises, uses Bitcoin NG protocol. This is chain-oriented data structure and the protocol, how to organize it. As I told you, we are proof of work, but we don't mine whole blocks of transactions. We just mine so-called key blocks. These are the colorful rectangles. The only thing in a key block is, from important stuff, is public key of a miner. When he becomes a miner, he also becomes a leader that can dispatch transactions verified by him and signed by him. So the big takeaway is really rapid confirmation time of transactions. What Emin said, 3 seconds, that starts to be usable in applications. That starts to be nice and opens a lot of opportunities. And here, it's important to realize difference between finality, which is a very technical term, and transaction latency that touches users. So, as you see, here is a chain structure with this tiny branch that goes to the top. When we talk about so short times like 3 seconds, actually a transaction is not able to travel the whole Earth in 3 seconds. So the next miner will not mine on the very last block of the previous miner. He will mine like the third from the end or the fourth. It's all fine. It's a healthy chain. And what happens with transactions from those 2 blocks, they get rewritten to the first block by the new guy. And this writing again is changing final state, final structure of the chain. That's the finality. This is a little bit, it's still technical talk. Let's look at the engine, what's going underneath. So let me explain the situation in detail. We had those 2 blocks that they were missed by the next miner, block X and block Y, and the transaction are filling up the first or next blocks of the new miner. Technically, those 2 blocks are discarded and transactions from them get to mempool, so the mempool rises. And even though from user perspective, his transaction at any time was confirmed, because first it was confirmed by the old leader, then briefly it gets to mempool and it's re-signed and reconfirmed by the new leader. So from user perspective, it's all fine. But from finality point of view, it's not that great, because transaction changes the place where it is in the chain structure. So now we get to those pools that the presentation is about. How they work is they have one server, which is part of the peer-to-peer network, and it's a edge server of their own dedicated ecosystem. Those they have a dedicated mining library, and they dispatch work to those workers. These are real people, real clients. They have business model behind it. And what the problem is, we discovered pretty soon, is that they refresh the work for their clients not as fast as we would like to. For sure, not every 3 seconds. In very pessimistic scenario, it can get to 1 minute. It means that the chain of blocks they missed may even reach 20 blocks. So it's still, everything works correctly, but it hits the finality that we talk about. It doesn't hit the user experience, but it hits the finality. Also, everything, as you see in this slide, is more extreme than in the previous slide. The branch of the fork we called micro fork is longer. The first micro block with transaction is filled up. Maybe even we need couple micro blocks because they have limit of gas to rewrite those transactions. And the mempool for this brief time when the branch is invalidated got really big. So it's not only hitting the protocol and the finality, but also the stability of the node potentially when the mempool gets big. So here we come to the Stratum, how to solve it. We decided we'll provide reference implementation of the pool mining software. We'll use the Stratum protocol, which defines how mining workers and coordinating server communicate, but we will do more. We'll solve those issues and make it in a way that it's compatible with our Bitcoin NG and Eternity NG protocol around the chain. So the first goal was education, because we contacted pools, we explained the problems, but nothing transfers knowledge like piece of code. It also, the second goal, will improve performance, because less communication, less thrown out micro blocks, and finality, this thing that everyone forgets, but it's still there, and it may be the most important thing that is in a blockchain, finality of transactions. And here is how it works in our implementation. So the edge node of the pool, he observes the chain, and he tries to dispatch the latest microblock possible. It's possible because he's tightly integrated with the full node currently. You actually can enable this edge server mode, we call it Stratum mode or Stratum server, with configuration. Everything now is baked into the full node. Of course, be careful with that. It has large consequences, but you can do it. To make it even more convenient, we add payout contract. So whatever rewards the network is getting, they can use a payout contract for their client to distribute Eternity tokens rewards. And there is a whole bunch of things to configure. For example, the dispatch, the broadcast of the work to your working clients. So this is the it's now ready. It's available. If any of you have full node, you can try it out. You can create small pool with your friends. Some details. There is the payout scheme we implemented is PPLNS. It stands for Pay Per Last N Shares. It's a big competitor of very popular Pay Per Share schema. And the improvement here is it analyzes contributed work over larger span of time. Thanks to that, the work contributed to mining is more stable. There is no hops and changing chains and being on and off. You benefit if you work with the server in stable and constant manner. So I think it's beneficial to this subsystem. And there is a tiny thing, target adjustment to computing power. I mentioned that because it's so neat. It's such a even implementational level trick, but it enables even the smallest devices to participate in mining. So even if you have like not the most recent GPU, you can contribute to mining or even a smaller device, and the algorithm will compute your own target to make your work meaningful. And you participate with the rewards according to the difficulty you contribute. But it's still, so it's probably not the biggest, but it's great how it empowers even the smallest participants. So it's also part of the Stratum implementation that we give. And what's next? As I said, it's in beta. It's in full node. You can enable, but there is a whole bunch of work to do to expand it. For now, we wait for community responses, for community feedback. Try it out. Let us know what's missing. What could we do better? For sure, we could improve security because such a server is open to the world. It's open server. So, as any web server is prone to DOS attacks and similar. So, but being in a blockchain space, we have tools to mitigate it. We can introduce some proof of work to join and so on. So that's the area of improvement. But let us know. Let us know if it's a problem. We consider stripping away any mining functionality from a full node, and we would like to put it in dedicated framework. I think it would make a lot of sense and would make full nodes code cleaner and have separate system to optimize the mining system. So that's the second thing we are thinking for the future. And finally, we would like to make it even more flexible, to configure even more things. So that's the plan if Stratum implementation takes off or adoption takes off. And yeah, that's all what I wanted to explain you. Thank you.
Thank you. You know what? Let's maybe do a quick question because you did it really well. So, does anybody? No, you hold this.
Okay,
We'll have another one. Does anybody want to ask a question? I saw a hand there. I'm gonna bring a mic to you. Oh. Please.
Thanks. Yeah. So if I understand correctly, then this problem that full blocks are sometimes mined not on the latest micro blocks is now being solved by basically the client, I mean the miners themselves, and by providing some, basically build it into the full node, the reference implementation, make it easy to pick it up. But it doesn't really solve this problem on the protocol level, right? I mean, if like a malicious pool that tries to sabotage the chain could still go ahead and still exploit this. Is there a way to prevent this on the protocol level?
It's actually it's equivalent of empty blocks in Bitcoin protocol or Ethereum protocol. So you can always do it. And over time, it will self-fix itself when the fees start to represent more values. So we also, our reward scheme for miners, we designed this inflation curve that lowers the reward over time. So there will be more pressure on fees, and miners will take an effort to be on the latest microblock. Regarding the malicious scenario, it exists. It exists because it exists in another protocols. You can be malicious, and but you pay for that, right? You will pay for that. It's basically attack. Oh, that's right. Thank you. There is another incentive behind fees, besides fees, for the following miner. We split the reward of the Coinbase, basically, and the following miner gets 60% of the reward. So, and the fees. So the more microblock he follows, the more fees he gets. It's kind of what I said. When the fees are more substantial, he would like to follow the most recent microblock.
Okay, thanks, Michael. I think you finished explaining, right? You
Yep,
answered this question, right? I wasn't sure if I was interrupting or not.
That does make sense for you?
Yeah, okay. Round of applause for Michael. Yeah, thank you. Thanks.